I want to tell you a little bit about what a CoinJoin is before I get into how to do them. And before I get into what a CoinJoin is, I actually want to tell you what a Bitcoin transaction is. So this is a Bitcoin transaction that I made in Excel. And every Bitcoin transaction has a number of fields, including the version number, which is I always use 2. I always use version 2. That's been the number we've been using for like 10 years or something. But that's the version number. Down at the bottom, there's a field called lock time. And the lock time field is not usually used. It's sort of used for like post-dating a check. If you've ever written a check and then we're like, you can't cash this until March or something, you can do that with lock time. You can create a Bitcoin transaction and say this isn't a valid transaction until block height 1 million or something. It's rarely used though, and it's kind of finicky to use it. But the main things that we use in a CoinJoin are the inputs and the outputs. And you can think of the inputs as the addresses you're sending from, and you can think of the outputs as the addresses you're sending to. It's a little more complicated than that. Like, it also includes the amount, and it includes a TX ID, and it includes some other stuff. But I like to think of them that way. So in this example, we've got a guy who has an address with 11,000 sats in it and an address with 15,000 sats in it, and he wants to send somebody 20,000 sats. Well, that's a problem because neither of his addresses has enough money. So he's got to combine 2 of them together over there on the left in the input section. He's saying, I'm going to spend from both of these addresses. And then he's got to say, all right, I want to send, whoever I'm sending money to, I want to send him 20,000 sats. And then he creates this thing called change, where after 11,000 plus 15,000 adds up to 26,000. That's more than 20,000, so he's got 6,000 left, right? So he sends that back to himself, and we call that a change output. And then he pays a little bit of it as fee to miners. I'm having him do a 200 sat fee. So that's kind of what a Bitcoin transaction looks like in Excel. Is everyone able to follow along and understand what I'm showing here? Cool. So one of the things you can do with Bitcoin transactions is you can batch them. You can make a big transaction that has many people in it. And exchanges do this a lot. They've got a lot of users. They often batch them together. So here I've got input A, we're going to pretend has 7,000 sats, and we've got a guy here who's sending 2,000 sats to somebody, and then he's giving the remaining 5,000 minus a small fee to somebody else or to himself. And then the next guy's got 28,000. He's giving 21,000 to somebody plus a little change output for himself. So this is you might do a batching transaction this way. And one nice property about batching transactions is everybody gets a lower fee because they get to share the fee among themselves. Instead of paying 200 sats, each guy's only paying 100 sats. And it's kind of neat. So you get lower fees if you do batch transactions. Cool? You guys following along here? What we're looking at? So when we get into CoinJoins, what we want to randomize the inputs and the outputs. So here, the numbers are all the same, but I've randomized where they're ordered on here. So we've got, output 5 is right next to output 10, and some of them happen to be equal amounts. Right here, the guys at 5 and 9 happened to both be sending 4,000 sats. But if you're looking at this, you might think, oh, we can randomize stuff, and that'll make it hard for chain analysts to figure out how to follow the funds, because everything's been randomized. But it's usually pretty easy for them. For example, down here at input 7, where it says he's got 90,000 sats, if you're trying to figure out which input that comes from, who can figure that one out? He can. It's really obvious. It has to be the biggest one. So yeah, that's some of this stuff is really easy if you're just doing unequal amounts. The ones that are hard are these two over here. If these are randomized, 5 and 9, you don't really know if that goes with A or E or maybe even C could have one of those. So that kind of makes it a little difficult to trace. Equal amounts are a good idea. Also, there are no labels. On here, you can kind of tell that A goes with 1 because of the label, and B probably goes with 3 because of the label. But on Bitcoin, we don't actually label them. There are no labels saying these outputs go with these inputs. They're all just unlabeled things. So that makes it a little helpful. But what we want to do is we want to make equal amount outputs. So in this case, I've made all of them 4,000 sats. Everybody's sending 4,000 sats to themselves probably, or to someone. And then you only get the change is able to be easily mapped to whoever sent it. Like you can pretty easily tell that the guy who had 5,000 sats gave somebody, he's got one of these 4,000 sat outputs, and he's also got the change of 900 sats. And that's toxic because you can easily identify that it must belong to this guy, the guy with the smallest amount. But yeah, the equal amounts help with coin joins, and so that's kind of what we want to build, is a transaction that has, it can have a bunch of different inputs of a variety of different sizes, but at least the equal amount outputs will not be traceable to their inputs, because you don't know. There's no labels or anything to tell who put which one in. Everyone good on what a coin join kind of looks like in Excel? So now we're going to try to build that in software, but there's a flow we got to do first. So in the flow here, we usually have a coordination server, and there are 3 rounds of communication between the users of the CoinJoin software and the coordination server who's helping them do this CoinJoin. In the first round, they register inputs. They say, these are the addresses that I'm sending from, and they also register a change output. They say, after the CoinJoin, I would like to receive, the sum of my inputs minus however much the CoinJoin is for, let's say 1 million sats. I would like to receive the sum of my inputs minus 1 million sats into my change address. And the change address is toxic here, but that's fine. It's already toxic in a normal coin join. So the server can actually see exactly which change output everyone's getting, but that's fine. Everyone on the blockchain can see what change address goes with which inputs. Once the server has the inputs, he gives them something called a blinded signature. And if you've never heard of blinded signatures, let me tell you a little bit about them. Blinded signatures allow somebody to sign a message without seeing its contents and verify later that they really signed it. We use them in coin joins to prove that you sent an input. Like, you registered an input with the coordination server, he gives you a blinded signature, you unblind it and send it back to him, and he can validate that he signed, that he interacted with you, because he can see a signature, but he doesn't know what he's signing. He doesn't know what he signed. So all he knows is you were one of the people who registered an input. And that's important, because in round 2, we're going to register our outputs, and everybody wants to do that part. Everybody would like to receive 1 million sats in a coin join, but they wouldn't necessarily like to contribute 1.5 million sats to a coin join. So the coordination server uses this blinded signature technique to ensure that everybody who gets an output also was part of round 1 and registered an input. But the nice thing about them being blinded is he can't tell who's who. He knows you were someone in round 1, but not who. Once everybody registers their output, he checks the blinded signature to make sure that they were part of round 1, and then he prepares a Bitcoin transaction. And it's nice because he's got all of the inputs over here from round 1. He's got some of the outputs from round 1, which are the change addresses, and he's got the rest of them from round 2. So he's got all the inputs, he's got all the outputs. All he needs to do is list them in that Bitcoin transaction, give it a version number, give it a lock time, and now he's got a Bitcoin transaction. But it's not signed. Everybody needs to sign this thing. So that's what he does. He submits this transaction template to everybody, and in round 3, everybody validates that they're getting the right amounts. They're validating that their CoinJoin address is getting, 1 million sats, and their change address is getting, their inputs minus the fee, minus the CoinJoin amount. And everybody checks their own addresses, and then they're like, okay, I'm getting mine, so I will sign this transaction. And if anybody doesn't sign, the transaction doesn't happen. So this is good. It's like, you don't have to trust this coordination server, and he broadcasts the transaction, and then you're done. The problem is, coordination servers are getting arrested right now. The guy who's running on the right side doesn't exist anymore, because Samurai got arrested, and Wasabi just stopped doing it. You can still use join market, which is great, but I want to show you how we're going to do this without the server. Oh, I had this version that I forgot to use where I would have gone through step by step, but whatever. So here's how we're going to do it without a server, and this is what we're about to build. Everybody is going to publish to a bulletin board, so not a server or not a coordination server, but just a random place where you can put data. Everyone's going to publish their inputs, a change address, and a pub key for use in something called a ring signature. If you haven't heard of a ring signature before, they're used in Liquid and they're used in Monero. And I'm going to tell you a little bit about them. Let's say you've got a group of 3 people, and they all want to do this thing where they sign a message, or at least one of them signs a message, without revealing which one he is, or he or she is. So here they've got a little message called, one of us signed this message, but you can't see who it was. And then there's a signature on it, And you can aggregate all these three people's pub keys into something called a ring. And you can take the signature and pass it around on the ring. And you can see, okay, I know that at least one of these people signed this message, but I can't tell which one of them did it. So we use this in lieu of blind signatures because they work in a group setting. Sometimes they're called group signatures. You can tell that, so that's what we're going to use in our serverless version. We're going to publish a pub key in the first step in round 1 to a bulletin board. And then in round 2, we're going to aggregate everybody's public keys, create a ring with them, and when we publish our CoinJoin address to the bulletin board, we are going to publish a ring signature with it that proves we are one of the people who in round 1 submitted a pub key. And that's great. Then everyone can review that and say, okay, I know that the person who published this output also contributed an input, but I don't know which one he was. And we're doing the same thing the server would have done, but without needing a coordination server. We just need somewhere to post data. Okay, so then after we've done round 2, we do round 3. Everybody checks that the ring signatures are valid, and then everybody prepares and signs the Bitcoin transaction. In order to achieve randomness here, what I'm doing is I'm going to randomize, or I'm not going to randomize, but rather I'm going to alphabetically sort the inputs and outputs. Inputs always have a transaction ID in them. Transaction IDs are a hash, and so they're random numbers. So if the inputs, we order them by the transaction ID, then they get randomized. And then as for the outputs, those are always public keys in Taproot. This thing is built on Taproot. And public keys, when you derive a public key from a private key, you don't know what you're going to get until you do it. So it's random. Thus, if I sort by the ATX IDs on the left side and by the Bitcoin addresses on the right side, I get random sorting without needing to do, and it's deterministic. Like everyone who's in this CoinJoin can prepare the same transaction. So everybody gets the same transaction, they sign it with their Bitcoin key, and they send their message to the bulletin board, and all this happens in round 3. That's the hard round. And then it's broadcast time. Everyone can just pull those signatures off of the bulletin board, validate them, and broadcast the Bitcoin transaction. And if at any step, anyone contributes an invalid Bitcoin address, or an invalid ring signature, or they just don't contribute anything at all, we have a procedure, which I have not yet implemented, for kicking them out. Basically, you require them to publish the private key of their ring signature, and that proves the linkage between what would have been their inputs and what would have been their outputs. And someone won't be able to publish valid data for that because they didn't follow the protocol correctly, and then you kick them out and do it all over again without them. But I haven't implemented that, and that's forthcoming. Right now, it only works if everyone is nice. Okay, so that is what we're going to build, and I don't think we have too much time to build it. We have about 40 minutes, so let's get to it. You guys ready to build this thing? All right, sweet. So I am a weird developer in that I always develop things in the browser. And the reason I do that is because in demos like these, I don't have to waste 20 minutes getting you all to download Rust or something and then figure out, oh, my dependencies don't work because I don't have whatever. Everyone's got a browser, so we're going to develop in the browser, and that makes it so everyone can be on the same page. So open up a new folder, create a new folder in it called, I don't know, you can call it whatever you want. I'm going to call it MSB. So that's the name of the software, MSB. Everybody's going to be an unregistered MSB. And we're going to create an empty file in here called index.html. We're going to open that up in any text editor. I happen to be using Sublime Text Editor because I like it. You can use whatever text editor you want. People at my workshops often use Visual Studio. I've seen people use Notepad. One guy tried to use Microsoft Word. I do not recommend that one. But we're going to copy the code that we see in here, and we're just going to paste it right into our index.html file. And then, you know what we're going to do? We're going to open it up. Open it up in Firefox or Chrome or whatever your browser of choice is. And this is beautiful. We have no errors. The perfect application. I also recommend opening up your browser console. In Firefox, you do that with Control-Shift-I. I believe in other browsers, you may have to go to the little menu, wherever your menu is, and then Tools or More Tools and Web Developer Tools. You should see it somewhere in there. Or you might be able to get away with Control-Shift-I. But you need your browser console open, and then make sure you're in the console tab like I am. So usually multiple tabs. So we're going to be looking at stuff in there. All right, everybody with me? We good? No errors? All right, sweet. I did have a guy have an error at this step once. It's like, but whatever. I don't want to say what happened. There are some things that should not be spoken. All right. So the next thing we're going to do is import dependencies. And for our dependencies, let me make this bigger so you can see what they are. Let me tell you about them. One of them is msb.js, which is it's got a bunch of functions in it for interacting with Nostr. That's what we're going to be using as the bulletin board for sending messages to. It's got a bunch of functions for creating inputs and outputs in a Bitcoin transaction. So you can check out the code there if you want to. If you want to see what it is we're working with, it's all right here, msb.js. We've got some stuff for interacting with hex, turning hex into bytes. We've got SHA-256, something for creating inputs, something for creating outputs, and then a bunch of Nostr stuff for interacting with the Nostr as a bulletin board for our stuff. Other dependencies for this include qrcode.js. That's why I was able to show a QR code when we put the address up. Something called ringsig.js, which is a library I created, sort of. I actually just found an existing ring signature library and then packaged it for the browser. But you can check that out if you want to see how ring signatures work. And then we've got TapScript, which is how we create Taproot transactions in the browser. Topher, are you in here somewhere? I think he was going to be. He wrote it. And then we've got Noble SecP256K1, which lets us interact with Bitcoin's elliptic curve and create private keys and public keys and stuff like that. So those are our dependencies. And the next thing we're going to do is we're going to add some style to our page. I know our page is empty, but it might as well be a pretty empty. So just pop this right down here. I'm also going to indent it properly because I like things to be indented properly. Close enough. All right, save that. Let's check out our blank page and see if it looks any better now. Whew, look at that beauty. That is so much better. I love when we apply styles and everything works. I'm really just looking for errors. I don't want to see any red things. It's like, oh, you forgot a semicolon or something. All right, so we're good so far. Next thing we're going to need is jQuery syntax. And I don't like jQuery, but I do like one thing the jQuery people came up with. jQuery was this kind of programming tool, I guess, that was developed back in like the 90s. And they did a bunch of stuff with making it easier to work in the browser. And of all the things they did, it's like 10,000 lines of code. I only like these two. These two pieces of code right here allow you to use a $ to grab elements on your page and then bring them back out. So I always import these two lines from jQuery into all of my projects because I like them, and they make working with the browser much easier for me. The next thing we're going to do is we're going to create our wallet. And you put this one in the body of your document. And if we save this, we should see the semblance of a wallet inside of our browser. So let's check this out. Not that one. No, I don't need him anymore. Refresh this. Look at that. We got a wallet. Now, it doesn't do anything yet. These buttons don't ever do anything yet because we haven't programmed them. And the balance will never finish loading because we have no Bitcoin addresses to even check. But this kind of looks like a wallet, and that's good. We're getting somewhere. Okay, so that's where we're at. Next thing we're going to do is we're going to begin adding some programming to this page. And the first thing we're going to need is a modal. So just put this at the bottom of your body. And a modal is a little pop-up that can show you information. So let me show you how we're going to use it. If I run the command show modal, and then I put some piece of text in there, it'll just pop it up for me. And it also supports HTML. So if I do line breaks or something, then we get line breaks, which is really nice. And you can X out of the modal either by clicking the X or by clicking the background. Nice. That's how you do pop-ups, ladies and gentlemen. At least that's how I do pop-ups. Okay, so we got that all working. The next thing we're going to need is to program our receive button so that it does something. All right, so let's take a look at this code. We're creating a function called receive. When we call the receive function, we use the MSB library, to create a private key and a public key. And then we get a Bitcoin address. From that, we just turn the public key into a Taproot address, because in Taproot we send directly to a public key. So that's good. And then we push the private key to a little object that I call state, so that we store it as a cookie. We actually store our private key as a cookie. Do not use this for actual funds, because any extension you have can read your cookies and steal your private keys, and that is how Ethereum works. All right, don't need you. So if we refresh this and then click receive, we can see a little Bitcoin address pop up in our console. So we're getting somewhere. That's working. So the next thing we need to do is we need to improve that receive button so that it uses our little modal to show us our Bitcoin address with a QR code. I'm going to copy this, and I'm going to paste it. I'm just going to replace this line that says session storage with the new one that also says session storage, but then shows the modal. So if we do that, and then we refresh our page, I don't need this guy or this guy right now, and click receive, check it out. We've got a little modal that has a Bitcoin address in it, and you could send something to that with another testnet Bitcoin address. Pretty neat, right? We're getting somewhere. We got the receive button working. Okay, so receive works. The next thing we need is we need to check if we've received any coins. Because if you send money to this address, or fake money, we're all doing this all in the testnet. If you send money to that address, it won't really show up because we haven't programmed it to even look for it. So that's what we're going to do next. We're going to create a function called getUTXOs. Just put it right down here at the bottom of our script. And getUTXOs will reach out to mutinynet.com, which is my favorite testnet. It will go through our private keys and plug each of our addresses and derive the addresses from them, and then ask MutinyNet, is there any money in this Bitcoin address? And MutinyNet will give us back an object which we then store in state, so that if we refresh our browser, it'll still be there. The money will still be there. That's what I mean by storing it as a cookie. So yeah, that's what this function does. And then we need to call that function on a loop. So this little loop down here, see what that does. It has a ... at the bottom because we're going to add to it, but ... is invalid, so you can delete the ... So what does this do? Well, if you save right now and refresh, you'll get an error, and I will show you the error. Yeah, uncaught syntax error, missing closing bracket, because we haven't finished this function yet. It's only halfway written. So don't save and refresh like I just did unless you want to see an error. But what this is going to do is, on a loop, it's going to go through all of our UTXOs, all the UTXOs we've stored, and check if they still have money. Like, check if that UTXO is still unspent. Because our wallet, we're going to be occasionally spending our UTXOs, and we don't want them to stay there. We want it to get rid of them if we've spent them. So that's what this first part of the function does. It checks if it should keep a UTXO by seeing if it still exists, and if it does still exist, it keeps it. Otherwise, it gets rid of it. The next part of the function, which is right here, complete the loop. This one, indented properly, goes through all of our private keys and checks if they have, and it passes them into the getUTXOs function, which checks if that private key's public key address has money in it, and then creates a UTXO for us. So by doing that, we add to our state of UTXOs whenever we receive money, and then we check our balance. The last thing it does is, on a loop, it calculates the sum of all the UTXOs you have in your wallet, and then it updates our balance divs, the toxic balance and the regular balance, to say, okay, this is how much money we have. And it does that every 10 seconds. So if we refresh our page now, and we go to click receive, and then we send money to this from MutinyNet. So I'm going to go to faucet.mutinynet.com, give myself 20,000 sats. Then after about 10 seconds, we should see, you have to X out of the pop-up. I have not told it to automatically get rid of the pop-up when the money comes in. But, I also forgot to call the function. So let me do that. I have to call the function. Run the loop is the next slide. So we put this at the bottom of our page. Save and refresh. And now it detected that we have 20,000 sats. So there we go. Nice. Is everybody on this page? Or getting there? Or not seeing too many areas? No, you're all lost? Okay. Okay, there's going to be a live stream, and I hope the audio works now. So you can also follow the live stream later to follow along. Or you can go to the GitHub where it's already completed and just open it up and be like, I'm skipping to the end. So that's another option. All right. So now that we've got the receive button working and we can detect UTXOs we've gotten, I've been told the live stream is working. Great. Awesome. Now that we have the receive button working and we can detect when we've received UTXOs, it's time to make the join button work. And as you might imagine, this is the heart of the wallet, and it's kind of a long it's a long function. 19 sections for this one. But, you know, I think that's to be expected because this is what the wallet is for. It's going to be the thing that takes the longest. Okay, so the first part of this in round one is the part that I am the least satisfied with in my code base. And it is because somehow we need to figure out how many people we're doing our CoinJoin with. We need some sort of signaling mechanism to say, this is the time to start listening for people to register their inputs, and then this is the time to stop. Because if you start listening and people start registering inputs, and they keep registering inputs, and then more people register inputs, when do you stop? When do you come to a close and say, all right, it's been long enough, everyone who's registered so far, we've got to be done. I need to find some way to signal a start time and an end time without having a coordination server. And I've come up with a way that doesn't work, and that's what we're using. But basically, we start looking through the blockchain for a block that if we hash that block and treat its hash as a number, modulo the number 3, we'll eventually, probably the block we give will not be a 0. Will not be a 0 when you take it mod 3. But then we go to the next block back from that one and we check if that one modulo 3 is 0. And if that one's not, we go to the next one back. Eventually, we will find a block where if you treat it as a number and take it modulo 3, you get the number 0. And that is our starting signal. We look at the time when that block was created, and we say that time is when we begin listening for people to register for their inputs. So anyone who registers after that time is good, is in the group. And then when's the stop time? Well, it's the next block that comes out that has, if you modulate it by 3, it becomes a 0. This roughly means that every 3 Bitcoin blocks, we have a round. We have a CoinJoin round. Because we all know the start time, we all know the stop time, and as long as we're all listening during that start and stop time, it's good. This is also, however, I'm not satisfied with this because when I've tried to do this with multiple people, it doesn't work. So somebody who's a better thinker than I am, come up with a better solution for this. Alex has one. What do you got, Alex? Why not just use block height? Yeah, so what you could do is you could say like every block that ends with a 3, a 6, or a 9 is going to be a start, and then the next block that ends with a 3, a 6, or a 9 is going to be a finish. Yeah, you should do that. I should have thought of that. Yeah, one of the reasons why I'm not satisfied with this method is because, well, I actually forget why it doesn't work. But it hasn't worked for me. So someone come up with something, try what he suggested. Maybe that'll be simpler. Anyway, once we've decided on who's going to be in the round, we state what amount we want the CoinJoin to be for. So you can have different amounts in these periods. Somebody can be doing one for 10,000, which is what we're going to do. Another group can be doing it for 1 million. But we publish what amount we're doing it for in our CoinJoin message, and then everybody goes with the group that matches whatever the amount they decided. I recommend using round numbers for this part, but I'm doing 10,000 sats for my CoinJoin rounds. Then we use a get UTXOs function from my MSB library to take our list of UTXOs that we have in our wallet and find some that sums to an amount that's greater than the amount in our CoinJoin, which is like what we were doing in round 1 earlier in the graph in the chart I showed earlier. All right, so that's what that does. And then the next thing is we got to create a change address, because in round 1, there's 3 things we need to send out, if you remember. We need to publish our inputs, a change address, and a pub key for use in a ring signature. So, where was I? I think it was right here. Yeah. So we got our inputs where it says get UTXOs. Those are going to be our inputs. The next thing we need is our change address. So I mark the change address as toxic, and then it goes into our database as a toxic address so that we don't spend that money in another CoinJoin. There's special things you're supposed to do with toxic change that I haven't implemented yet. I just mark them as toxic and then put them in a kind of a separate section of the database. Okay, so that's what we do there. And then we generate our ring signature public key, the public key we're going to use for the ring signature. So now we have all three things that we need in order to complete round one. And so we send them out to our bulletin board, which I'm using Nostr for that. So that's what this section does. We create a little message, and we say, I'm participating in round one of this CoinJoin. We publish the amount that we're doing. We publish a fee rate, and I think I hard-coded in here to use 30 sats per byte as the fee rate because I have PTSD from the ordinals drama, and so that's what I'm using. I think really you should probably check what the fee rate was for the block that for the most recent blocks, and then have some kind of range that you'll accept from other people. But I haven't implemented that. Everyone just uses 30 sats per byte as the fee rate for preparing this transaction, and that works. Okay, so that's what we do there, and then we publish it onto Nostr. We send the event, and we say, okay, now everyone on Nostr knows that we're participating in a CoinJoin referencing the block hash of our current round. Great, we're good. Next, we get everybody's messages, and this completes a round. In computer software design, a round of communication is when you send out a message, and then you get back a message. That's a full round. So we have sent out a message right here to all of our peers, all of the people who are participating in this CoinJoin with us. And then down here, we get all events that match our template. We get all events that look like they're wanting to participate in round one as well. And so that is a complete round. We've sent out a message, received a message, and now we're in round two. If you look back at our little diagram, we are now here at step 2, where we are supposed to publish our output address. We want to say where we should get the 10,000 sats, and we have to include a ring signature. Okay, so that's where we're at, and round 2 begins. All right, paste it. I have not implemented the part where, what I'm supposed to do here is check that everybody's inputs sums to an amount that's greater than the CoinJoin amount. And if they don't, then we're supposed to kick those inputs out and not let them participate. I haven't implemented that, so if you cheat and then you send in 300 sats as an input, people will happily include you in this CoinJoin and you'll get free money. So somebody who's smart, implement kicking people out if they don't contribute a sufficient amount of inputs. I haven't done it yet. Okay, but we create some objects that we're going to use for preparing our ring that we're going to check the signatures against. We prepare an object for putting in all the inputs that are valid, and I just assume they're all valid inputs because I'm not checking. But we need to do that and kick out anyone who's not valid. And then we got change outputs. So we just register the Bitcoin address that everyone's going to use as change in there. We count the number of contributors because we're going to use that later when determining what we're paying as a fee. We have to divide the fee times the size of the transaction and then divide all of that by the number of people participating, and that gives us what we're paying as a fee. And then I have something called mapping, which I use for tracking which fee rates go with which change address so that I know how much to deposit into each change address. I do a little bit of validation down here that they sent in that everyone who's participating in round 1 contributes the same amount as me, and I only include the people in my CoinJoin who want to do a CoinJoin for the same amount. I only include people who are using the same fee rate, but this is the part where it really should be a range of acceptable fee rates because everyone's mempool is different. And I ensure that everybody only contributes a maximum of 2 inputs. You can contribute 1 input or 2 inputs, but no more, because inputs are the expensive part, and if you contribute a whole bunch of inputs, it ruins everything. It makes it so it's really expensive and everyone else has to pay for consolidating your UTXOs. So I just make sure you only have the ability to put in 2. Wasabi used to allow 7 in their coin joins, but that's very generous. I'm only letting you do 2. Well, yeah, but per message, you could only have 7 in each message, and then you could make another message if you wanted to contribute more inputs. Yeah, maybe I'm wrong. I might be wrong about how Wasabi worked there. At some point, I had the impression that there was a 7 involved, but okay. I'm being corrected live, but I appreciate that. Keep me honest, guys. I'm surprised it's taken this long for me to say something wrong. All right, so we get our inputs, and we get everybody's inputs. We add them to the inputs thing, and we check. Oh, actually, I am checking that the inputs sum to the right amount. Oh, that's cool. I did do some validation there. We add their public key to the ring, and then we add their inputs, assuming that they matched up. We add their inputs to the CoinJoin inputs thing, and then we move forward. Next step is to sort the ring. So we sort it lexicographically. That way, everybody has the same ring, because they might receive messages from Nostr in different order. And then I have to have the dummy key, because I found an error, a mistake in the library of the ring sig library that I'm using, where if you happen to be the last person in the ring, it will error. I think it has like an off by 1 bug where it tries to find the next person in the ring to calculate what the next part of the signature should be, and there is no next thing, so it fails. In order to correct for that, I created this dummy key, and we add that as the last member of the ring. And then no one who's actually a member of the ring has this private key, so that it never fails. It never checks against this one. Yeah, I really should use a nothing up my sleeve key, but I didn't do that yet. So this is just one that I generated, and you should not use this one for real. You can use it on Testnet, that's fine. Don't use it with real money, because you don't know if I have the private key. Okay, so we do that, and then we get our index after we find out which of the public keys is ours, and we create a signature, a ring signature, that is valid for one of the public keys in there, which happens to be ours. And that's what this function does, make sig. So then we create our CoinJoin address, which is not toxic. We're not marking this address as toxic, because it's actually the kind of address we want in this wallet. And we're going to send our CoinJoin address with our ring signature. And if you'll notice in our little graph, that is what we're supposed to do in round 2. We publish our CoinJoin address and include a ring signature. So we're following our diagram. So the next phase down here is to send that out to Nostr. So we do that, send it out to Nostr. I'm using kind 46,048 rather, for all of these messages. On Nostr, you can make up kinds, and it's wonderful because no one else is using them, since it can be any number between 1 and 65,000. So I just randomly generated this kind, and that's what I'm using for this event. It's one of the things I like about Nostr. No one else sees this unless they're specifically looking for kind 46,000 events. So it's not like going to show up in people's Damus client or something. It's great. So we prepare the event, we send the event, and we have nearly completed round 2. We just need to get everybody's messages. So that's what we're doing here. We get everybody's messages for round 2, and from round 2, and that's it. Then we've done a complete round, and we're now in round 3. Yay! We're most of the way done, 2/3 of the way done with our join function. So the last part, round 3, is the part that is the longest of the rounds. So what are we doing in here? Well, let's paste the code and find out. In round 3, we're supposed to kick out anyone who didn't submit a ring signature or submitted too many outputs to the CoinJoin, or who didn't submit any outputs to the CoinJoin. We're supposed to kick them out by requiring everyone to, if that happens, we require everyone to reveal their ring signature, and whichever people don't reveal the ring signature, we kick out, and whichever people reveal that they did 2 of them, we kick out, and all that stuff. But I'm not kicking anyone out because I didn't implement it, and I'm just assuming everybody's honest. But yeah, you have to kick people out if they're dishonest and aren't following the protocol correctly. And then you restart from step 1 with the remaining people. And it works. It always terminates, at least in theory. I haven't actually implemented it, so there might be a bug. But in theory, it should work. It should always terminate in a successful CoinJoin. But we get all of the outputs. I'm not validating the outputs, so this is another way you can crash this. You can send an invalid Bitcoin address, and then everyone will try to add that to a transaction, and it won't be valid because I'm not checking. But I should do some data validation here. That's for future work. We get all of the outputs, put them in an array, and eventually we're going to sort that lexicographically. I think we do that in the next slide, actually. Let me see. Yeah, we do. We sort that lexicographically so that everything is in alphabetical order. So we get the TX ID and the vout for each input, and we pair them together, and then we sort those alphabetically. And we do the same for the outputs. Except we do it with the Bitcoin address instead. And that gets us a random sorting of the addresses in the output side and of the input side, which is great. Then we prepare our transaction, which is now randomly sorted. And we can't actually use this transaction, though, because the fee, the amount we're putting into the change address is wrong. We haven't deducted the fee for this transaction yet. And then used that to calculate what the amounts for the change should be. So I think every change address right now has like 0 in it. And that's not standard, so you couldn't broadcast that. So to fix that, we do the next step, which is we get the size of our transaction, now that all of the inputs and outputs are in there. And that's what we're doing in this line right here. We multiply the size of the transaction in bytes times our fee rate, which is 30 in this case. And then we divide that by the number of contributors so that everybody pays their fair share for what they're doing. Then we go back through all of our inputs, and for every input that is a change address, that's what we use the mapping object for everyone that's a change address, we give it the amount of its inputs minus the amount of the CoinJoin minus the fee that person is paying. And that's their change. And everybody gets change. So we're good. Now we have a valid transaction, and it pays fees, so it can get mined. And at this point, we need to sign it. So, so here what we're doing is we're going through all of the addresses in the input side, checking if they're ours, if they belong to us, and if they do belong to us, then we sign the transaction and exit. I just realized that there's a bug here. Somebody could put one of your inputs as if it was their input, and then you would sign it. But that's only if they know your inputs, which they shouldn't know because they don't see your wallet. So we're good. That's not a bug. We're good. We're still safe. Still safe. Okay. So then we get our revised transaction with all of the outputs corrected for the change amounts, and then we've signed it now, or we've prepared to sign it. So we create a signatures object, and for every input we create the signature, add it to the signatures object, and then we're going to send this to the bulletin board. Because it's not enough for us to just sign our inputs, we also have to get everybody else's signatures, and everybody else has to get our signature. So we're going to use the bulletin board for this one more time. We're going to submit all of our signature to the bulletin board, and then get everyone else's, and then we'll be happy. So that is the next step. We make a different message for our new ring signature. We still have to prove that we're one of the people involved in this thing. I'm not actually sure you do, though, because if your Bitcoin signature was invalid, then people would just erase it there. Anyway, I'm using a ring signature again, so I make a new message. For the message, I just take the block hash, and I change every other byte to the maximum value, FF, and that is my new message. And I don't think that's insecure. I haven't thought about it much. So then we make a round 3 message. We send in our Bitcoin signatures and our ring signature. And then, this is the last round, we get everybody else's signatures. And we have completed round 3. By the time we get, oh no, we're still just sending. We sent this off to Noster. And then to finish it off, we get everybody else's signatures. And now we are done with round 3. So we've done all 3 of the rounds. The last thing is to broadcast, to put all of the signatures in the right spots and then broadcast the transaction. And then we've done a CoinJoin. Question, Maru? Yeah, I'm doing 10 seconds. You get 10 seconds to do. Once we've reached the next block that is 0 modulo 3, then everyone has 10 seconds for each subsequent round to do the stuff. And that's worked for me so far. So I've not had any trouble with that. If that was troublesome, if some people had shaky connections or were using Tor or something, we would probably need to extend that. But I'm using Nostr, which is fast, and it's worked so far. All right, so it's broadcast time. So we get all of the signatures from everybody from Nostr, and we check if they're valid and add them to our Bitcoin transaction. You can, of course, crash it here by sending an invalid Bitcoin signature, and then the transaction won't be valid. So if that happens, I need to implement that we kick out anyone who didn't send in a valid transaction, and then we redo it with the honest people who did submit valid signatures, and then we end up getting a CoinJoin anyway. So yeah, it always terminates in a valid CoinJoin, which is a property that I was careful to ensure. Lastly, we get the transaction hex from our transaction, and we show that in the little modal, and we say go broadcast it. You could broadcast it by pasting it into Bitcoin Core. I've been using MutinyNet. They've got a little transaction broadcaster on there, but you've got the transaction. That's the main thing. You could email it directly to a miner as an option. I've done that before. But that's it. There is a send button, but I don't think I want to implement that because I've only got 6 minutes left. But yeah, if you should implement the send button, and I think I need a final closing thing on this transaction, and that should work. We should have a valid software, except you can't send money. But you can CoinJoin, you can receive money, and you can CoinJoin, and that's really good. So that is the CoinJoin wallet. You can finish for homework, you can implement the send function by just copy pasting as I've been doing and make it send money. But are there any questions about coordinator-free CoinJoins? What's up, Alex? Yes, if you go to mutinynet.com/tx/push, you can paste the transaction hex right there, and it will go through. What's up? What do we miss by having a central coordinator? The CoinJoins get cheaper, so that's nice because you don't have to pay the coordinator fee. Yeah, what are the downsides of doing it this way? The change is more toxic than it was in the other ones, in Whirlpool. In Whirlpool, at least Whirlpool v1, when you had toxic change, there was a chance that your toxic change would be masked if someone happened to contribute the same amount of inputs as you. And then you would not have toxic change. It would actually be CoinJoined again because there's an equal amount. This never has that because you send your change in the same message as you send your inputs. So there is a one-to-one mapping between them. And that means our change is super toxic. So a coordinator helps you there. That's the downside of not having a coordinator, is you get super toxic change. Yep. Yeah, eventually it gets too small to put it into a CoinJoin. And then you can donate to the Samurai. Another question? The question is this a CoinJoin or a collaborative spend? Or is Whirlpool something other than Whirlpool is CoinJoin software, and it is collaborative spending software. And all CoinJoins are collaborative spending transactions, or I call them batch transactions, because there's multiple people and multiple people sending money to other multiple people. So they're all collaborative transactions. But not all collaborative transactions, not all batch transactions, are CoinJoins, because exchanges do them too, and they're not CoinJoining. Although they do show up as false positives in my CoinJoin Explorer, because they look like CoinJoins. Yeah, does that answer your question? Great. Any, what's up?
You thought this CoinJoin usually get flagged and you get censored. with this solution, do you think it's less possibility to get censored? And one other question is... Like,
well, let me answer that question first, and then you can answer do the second one. The question was, does this resolve the issue where if you have coin-joined UTXOs, you get censored? No, it does not. These are just as flaggable. They'll show up in a CoinJoin Explorer, same as any other CoinJoin. Some services won't accept coin-joined coins. So you can imagine, I don't think Bitrefill is an example, but I always use Bitrefill to buy stuff. And someday I can imagine going there and sending them my CoinJoin to Bitcoin, and them sending it back to me, and being like, return to sender, we don't accept these because it might be money laundered, or something like that. Yeah, so that is an issue with CoinJoins, is that they leave a footprint on the blockchain that you can tell that they've been CoinJoined. And governments might put pressure on companies. I think they are already putting pressure on companies to reject them and just send them back to the sender. Or maybe even someday they'll just be like, send them to the Treasury. The US Treasury would like those. But what was your second question?
You did like, okay, I'm waiting 3, or for example, I'm taking the mode 3, and you think that all these assumptions you make it. I know this is a beautiful piece of like a beta software. But
thank you.
But what you mean? Do you think this is a way to track kind of your algorithm and also to block from doing this CoinJoin, like a serverless or Nostro or whatever?
A Nostro relay could block these CoinJoins, and then you just have to find another Nostro relay or not use a Nostro relay. I thought it would be fun. You just need a place where you can post messages and read them. And the Department of Justice has a feedback form. I thought it would be great to use that as our coordination server. And then they would have to sue themselves as money transmitters. So. Thank you all.